Okay, it's just a bit of a measurement video. I've stopped the rotor and let it self-oscillate the system, which is also good to know because we now know we can use a bifilar coil as well with a core inside, and this enables us to boost up the system's input and output. We're running at 12 volts and our input current is 36.72 milliamps. We can calculate this straight away. 12 times 0.03672, so it's 440 milliwatts input. That is our L1 or globe 1. That is our L2. They are hooked directly in series, one after the other, and both are joined onto the positive side of our first cap. Our second cap goes out through this amp meter and that voltmeter, which we can calculate the output or the input that the coil is consuming. So we have our 8.31 volts times our 68.7 milliamps. It gives us 0.570 watts to the third digit. We have both our voltmeters across each one of these globes. Across our L1 globe we have 0.805 volts. Across our L2 globe we have 2.831 volts. Also have the scope across the output. We are set on 10 volt per division, and as you can see it is a very smooth DC, no pulses, 500 microsecond on the time divisions. So that's telling us around 8.3 to 8.5 volts, which is consistent with the meter. Of course we also have our globe as well, 24 LEDs being lit up quite nicely. So once again, it's 12 volts at 36.72 milliamps on our input to the system. We go through L1, R1, R2, which you can see the difference there between the two. Out of R2 into the cap, out of the cap, and that is what our coil is consuming. 8.31 volts at 68.7 milliamps, and like I showed before, it is a very smooth DC consumption because we have another cap, another 4700 UF cap right there, which the system is feeding off to smooth out all the pulses. So this setup right now will work as a motor, and it'll work as solid state, and like I said, that's not a very nice coil, but it shows us exactly what's going on in the system. Cheers guys.